Okay, so in this case, we've got oxygen reacting with C₂H₆O, and that produces CO2 and H₂O. And we've been asked to try and calculate, well, what's the mass of H₂O producing this particular reaction? So how am I going to approach this? Well, first of all, the C₂H₆O is in excess, so the implication of that is that the oxygen is really the limiting reagent, which is going to determine how much of the products are produced. And one of the other things I'll note is that the assumption in this particular case is that what took place was complete combustion only, right? This is an assumption for the sake of this question. It's not necessarily, there are cases where just due to a lack of oxygen, you might find some incomplete combustion might take place. But in this case, we are assuming complete combustion. Okay, so how am I going to go about calculating the mass of H₂O? Well, if we refer to the equation that links the mass to molar mass and moles, right? So that's effectively M equals M equals moles N multiplied by molar mass MR, right? In this case, for H₂O, we can find out the molar mass from the periodic table. When it comes to working out the number of moles, we haven't been told that information. So that's less straightforward. But what we do know is we know the mass of the oxygen, right? And if we can work out the amount of substance of the oxygen, right, we can then use stoichiometry to work out the amount of substance of the H₂O. So let's go about effectively working through this process and to figure out what the actual mass of the H₂O is. So if we consider the equation that links amount of substance to mass and molar mass, we had our original equation here, but if we effectively take the same equation but divide both sides by MR, we get that the moles N is equal to, because that will cancel out, right? N is equal to mass divided by molar mass, right? Now, one of the other things to consider here would be, okay, we've got the, so this would be N, so N of oxygen, right? .83. So that's the mass divided by, yeah, so we need to consider that we don't have the molar mass of oxygen given in the question. So we would need to figure that out from the periodic table. So if I refer back to the periodic table now, you can see oxygen here, 16. And we know it's O2, right? So this is going to be, simply put, the molar mass of O2 is going to be equal to 16 multiplied by, as you can see, it's O2, so it's going to be times 2. And of course, that's going to give us 32, right? And that's going to be in grams per mole, right? Okay, so aside from that, using that figure, actually, we would then, that would be divided by 32, right? So that's the MR in this case. And so I would invite you to have a go, see what you get when you work that out. So if you did have a go, you should find you get 0.7134375, and that's going to be in moles, right? Now, the other thing we're going to need to look at here is the stoichiometry, basically, because this is what we have here is the moles of oxygen. what we want to do is, okay, well, this is the moles of oxygen, but how does it compare to the moles of the H₂O, the amount of substance of the H₂O? Because this is how we're trying to get to the point of being able to figure out the mass of the H₂O. Well, if we put together a comparison, so the moles of O2 as a ratio compared to the moles of H₂O, what would we effectively write for that? Well, the coefficient in both cases is a 3, so 3 O2 and 3 H₂O. So it would be a 3 to 3 ratio. And if we divide both sides by one of the factors, which is 3, right, you get a 1 to 1. And what does that mean? Well, what that tells you is that the moles of, and we'll focus on H₂O, so even though this is O2 on this side, I'm going to put H₂O on the, let me actually use something slightly different. So the moles of H₂O is equal to the moles of the oxygen, which we already know what that is, right? Is equal to, we've got that figure here, okay, which is equal to 0.7134375, right? Now the other thing here would be, well, we're trying to work out the mass, not just the moles. So for H₂O, the mass would equal the number of moles of H₂O multiplied by the molar mass of H₂O, right? We have this here, we don't have this. So let's work out the molar mass of H₂O. You may already know what that is, but let's nonetheless go through the process. So the MR of H₂O would be, so hydrogen, we've got oxygen, right? So it's going to be 16 plus, and because that would be 16 times 1, right? Because the coefficient here for the oxygen is just 1. 16, so I'm not going to write the 1 because it's kind of redundant, but 16 plus 1 times 2. So 1 is relating to the relative atomic mass of the hydrogen. And of course, that's going to give us 18, right? So it's going to be 18 grams per mole. So if we now take that 18 back to where we were here, so this is therefore going to be equal to 0.7134375 multiplied by the MR of H₂O, which we just worked out, which is multiplied, therefore multiplied by 18, right? And if you have a go at that, you should find that you get 12.841875, right? That's going to be in grams. Now let's check what we've been asked to do. Calculate the mass of H₂O produced from this reaction. So we've done that. In the next step, it says give your answer to a maximum of 2 decimal places, right? As we have it here, our answer is effectively to 6 decimal places. So what we're going to need to do as an additional step is round this to 2, right? To 2 decimal places. So that's going to give us 12.84, right? So we're just rounding up effectively. Well, we're rounding this, but we're rounding down, right? Rounding down from 84.1872. Anyway, yeah, so grams, that would be grams, and then could just write here 2 decimal places. Yep, so that would be effectively our answer in this case, 12.84 grams.